guys, this week we're going to be looking at the discriminant, moving into the quadratic formula and stuff. So before we do that, I just kind of wanted to go back over some of the main number systems, mainly because we're going to be categorizing solutions as different kinds of things. So first, all numbers can be split into two categories, which would be real and imaginary. And the way you can tell the difference between the two is that imaginary numbers include an I for imaginary. We will get more into what imaginary numbers actually are later, but just know that if it's imaginary, it has an I, and that comes from, taking the square root of a negative. So like, mainly because, when you do a square root, excuse me, a negative times a negative is a positive, and a positive times a positive is a positive. So it's really hard to find a number that you multiply by itself that'll turn into a negative, and that is I, which is imaginary. So anyway, square root of -1 is I. Anyway, real numbers are anything that aren't that, basically. They can be fractions, they can be decimals, they can be square roots of positive numbers, square root of 15, 3.7 repeating, 3.5, they can be negative, positive, whatever. Okay. And then real numbers can be split into two categories, which are rational and irrational. So, excuse me, I know my allergies are being weird. The definition of a rational number is a number that can be written as a fraction. That doesn't mean it has to be a fraction. It can be, it could be 4, because 4 could be written as a fraction as 4/5. 4/5, 4/1. What am I saying? Okay. It could actually be a fraction, like 1/2. It could be a decimal that either terminates, like 2.75, or a decimal that repeats. So 4.78 repeating, or something like that. All of those can be written as fractions, and they can be positive or negative. So I could just make a couple of negative, either or. When you get into rational numbers, there's more ways to classify them. Like integers are like your counting numbers 1, 2, 3, 4, 5, but it includes positive, negative, and 0. Whole numbers, just take away the negatives. It's like 0, 1, 2, 3, 4. And natural numbers just don't include 0. So you can get further down into your categories, but right now we're just kind of looking at rational and irrational. An irrational number cannot be written as a fraction. So the most famous irrational number, I should say, is probably pi. Pi has a non-repeating, never-ending decimal, which is something that all irrational numbers have in common. They all have a never-ending, non-repeating decimal that seems totally random. Another famous irrational number is called E. That comes in later. If you move on to pre-cal, I'm sure you'll get a good look at E. If we have time this year, we'll talk about it when we get to the logarithms. But other than the ones that you're going to be most familiar with are square roots that are not perfect squares. So like the square root of 3. There's no quick and easy number that multiplies by itself to give you 3. So the square root of 3, therefore, is going to be irrational. If you had like the square root of 4, that would be rational, because the square root of 4 is just 2. Or the square root of 16 is 4. So if it's a perfect square, meaning that when you take the square root of it, there's like a whole number that can be the square root, then it's rational. Otherwise, it's irrational. So like the square root of 15 or the square root of 37. All of those would be irrational. Okay. So here's the quadratic formula. Isn't it beautiful? The discriminant is this part right here, b squared minus 4ac. And this part of the week, that's the only part that we're going to be messing with, partly just to get used to using the formula with a smaller chunk of it, but also because that particular piece gives us a lot of information about the quadratic that we're looking at. Okay. So this is something that I recommend that you write down. I hope you do, especially since quizzes and tests are like open notes that you're at home. This is stuff that you will need to know. But basically, the discriminant, sorry, I lost my train of thought. It's a number, right? So it can be one of three things. It can be positive, negative, or zero. Every number is either positive, negative, or zero. So based on that information, we can learn something about the solutions. So if you have a positive discriminant, that means that you have two real and what would be distinct or different solutions. Okay. Now those solutions can either be rational or irrational, depending on whether or not the discriminant is a perfect square. But if it's positive, it will always be two real solutions. And then if you have a negative discriminant, you know that the discriminant's under a square root, so you get an imaginary number when you stick a negative under a square root. So if you have a negative discriminant, it means that you have two imaginary solutions. Okay, so if you have zero, it means that you have one real solution. Now, if you look at that, it's because here we have the plus minus. That confuses people sometimes at first. It means that when you use this formula, you get two answers, because solutions are essentially x-intercepts. Okay, we're getting this by setting the equation equal to zero, which is the same thing as finding an x-intercept, and most parabolas have two x-intercepts. So you get one of them by adding the discriminant and then dividing, and you get one of them by subtracting the discriminant and dividing. But if the discriminant is zero, if you add zero or subtract zero, you're going to get the same answer, right? Because it doesn't do anything. So that's why there is only one solution in that case. So as far as the graph, like I just said, solutions are essentially x-intercepts, okay? So if you have two positive solutions, sorry, I was trying to draw on right at the same time. If you have two real solutions, that means that you have two real x-intercepts, okay? So what that means for your graph is that your parabola is going to touch the x-axis 2 times. It could be going down, it could be going up, it can be wide, narrow, all sorts of things. The only thing we know for sure is that it touches the x-axis twice. So if you have positive discriminant, your graph's going to look something like that, okay? If it's negative, if you have two imaginary solutions, it means that you don't have real x-intercepts. And since we are graphing in the real number plane, they don't show up. So that's going to be a parabola that never touches the x-axis. So if it's going up, it's going to be above the x-axis, and if it's going down, it's going to be below, but it will never actually touch. If you have 0, that means that the vertex is actually on the x-axis. So it could be going up, could be going down. Either way, doesn't really matter. That is the only possible way to have a quadratic with one x-intercept, is if the vertex is your x-intercept. Because if I take, I wonder if I can move this at all. Well, anyway. If I take that parabola, if I move it up or down, it's either gonna have no x-intercepts, it's gonna start having two x-intercepts. The only way to possibly have a parabola that has only one x-intercept is where the vertex is on the x-axis. Okay. So this brings us to actually using the discriminant. So the discriminant is b squared minus 4ac. Normally I would have this formula written on the board for you to use. I don't have a board. You probably won't be doing this. You'll be doing this on your own. So make sure you write down what the quadratic formula is. That's probably one of the easiest things to find by Googling. And remember, we've worked with standard form before. Okay. We have A, B, and C. A, B, and C are just numbers. Do not plug X into any formulas. It's just the numbers. People always confuse themselves. It's not X, it's just the number. So in this case, B is going to be -3 squared. Make sure you put negatives in parentheses. You can really just put every number in parentheses, but especially with things like negatives and fractions and stuff like that to show that it's all one number together. Can't tell you how many times people type this in the calculator and get the wrong answer. So anyway, -3 squared minus 4 times A times C. So you can just type that straight into Desmos or GeoGebra or a calculator that you have, as long as it's scientific, because order of operations matters. Or you can do that it's 9 plus 20. So 29 is a positive number. If you don't remember, that's why I said to write this down. Go back and look. You have two real solutions. Two real solutions. That's all you have to do right now, okay? At the second half of the week, we're going to actually find out what those solutions are. But right now, it's just two real solutions. That's all you got to do, okay? Excuse me. So sorry. I hate my nose. It's running all the time. All right. Here's another one. Same thing. So A, B, and C. So I've got B squared minus 4 times A times C. So the 4 is part of the formula, but everything else I got from the equation. Okay. That'll be 16 minus 40, which is -24. Well, -24 is a negative number. So if you go back to that table with a negative, that means that I have two imaginary solutions, okay? I'm abbreviating. You are more than welcome to do the same on your work. Two imaginary. All right, last one. Okay. So I've got A, B, and C. Again, please put numbers in parentheses. See, I even put the +4 in parentheses there. Just get in the habit of putting every number in parentheses when you're plugging stuff into formulas, okay? Do yourself a favor. It just makes your life easier. Anyway, B squared minus 4 times A times C. So So that's going to give me 16 minus 16, which is 0. Oh my gosh. What does that mean? That's neither positive or negative. Well, hey, I wrote it down on my handy dandy table. That means that I have one real solution. Oops. One real solution. So, like I said, that is what we're doing the first half of the week. That's all you have to be able to do right now. We'll look into finding out what the actual solutions are for the second half of the week, but we're easing into it. The quadratic formula, if you take it one step at a time, it's really not as bad as it gets a bad reputation. Anyway, hope you guys had a good weekend, and I will see you guys at the live meet.